No, because it's already past 3:05.
So, yeah. So, hello everyone. So, thank you for joining us today. Today we are here for a training session where we will learn about what are JSON Web Tokens and how can they help manage your user sessions efficiently, and also how are sessions used and used with JWT, and how can you make lookup faster and more secure to ensure a seamless user experience. So, and also, if you have any questions while the session is going on, you can ask in the chat. And also, if your questions are not answered while in the session, we'll get back to you at the end. And also, you can mail us at Valuebound. So the webinar is also being recorded and it will be forwarded to all the participants. As you all know that our today's speaker is Sandan Satish, an IIT Delhi alumni and a principal software engineer at Valuebound. He has extensive experience as a full stack developer and an engineer. So working with CNN for image processing, he has been working with CNN for image processing. With his expertise, Sandan will guide you through the basics of JWTs and explain you to use them with efficient session management. So I welcome Mr. Sandan and you can take it over from here. Thank you.
Thanks, Prem. Good afternoon, everyone. By the way, is it already recording? Yeah, okay. All right.
Yeah.
Good afternoon, everyone. So today I'm here to discuss one aspect of backend web development. Mostly, it's exactly web development in a sense, not exactly just backend web development. That is the use of JSON Web Tokens. For those of you, I think a lot of you would already be knowing about it, and if not, we'll anyways discuss about it in more details. So let me just quickly start the presentation. Let me share my screen. Okay, so the point of this session is to discuss how user session should be managed so that it's efficient and it is also user friendly in terms of experience. So that is why this JWT, which is one of the most popular forms of tokens to use for authentication in the entire web API process. So there are a lot of potential dangers about it, and there are a lot of debates about it, and we'll just go through that in details, and we'll try and find a way around it. Okay, so let's just start with what are JWTs. JWTs are JSON Web Tokens. So they're used for managing user sessions, obviously, and if you are aware of the structure of JWT, we'll also come to the structure of JWT as we go ahead in this presentation. That JWTs contain all the user data. Basically, if you have a user table, so one tuple or one entry, one record, one row, whatever you want to call it, one document in terms of Mongo, that is stored completely in the token as information, and it is encrypted using some using maybe HSA 256 or some algorithm, which is also mentioned in the token, and it is also signed. We'll come to the structure later, but this is done so that you can keep the user logged in, and you don't need to consult the database every time to get the user data. So if a user is making a request, so suppose I'm in an e-commerce site and I've logged in and I want to add something to my cart. Now this is allowed when I'm logged in. I can view products when I'm not logged in, but if I have to add something to my cart, I have to be a logged in user. So I'll just send a token. From the token, the backend would know and read which user is sending the request, and then accordingly, it will just update the database for that user that this has been added to the cart and send it back to the user. Otherwise, it would be a two-step process. But the problem with using JWT is mainly related to the security. And there are many things which you can do as a way around, but it doesn't really work in that sense. And we'll discuss that in details. And if you're aware of Okta, which is a major identity and access management organization, so all the security experts in Okta have already suggested that we should stop using JWT, and the independent security researchers have also pointed out the same. But the thing is that JWT is so widely used in the industry because it is so popular and it's so easy to use and implement that people are still looking for a way around it, whereas security should not be that sort of a question. Also, before going any further, I would just like to give credit to, let me just go back to the previous slide. My screen is stuck. Yeah. So this information was summed up by Will Johnston, who is a developer in the industry for the last 15 years. He gave a webinar on Bright Talk, and he had covered all aspects of JWT. So my presentation is based on the same. So let us start with the absolute basic before going into JWT of what the problem is. And basically how the web structure is. So I'm just taking a use case social media, and this is one diagram which all web developers would have been familiar with. Like this is the very basic, the very starting diagram, which I explained before you become a web developer, that this is the high level architecture of any web application, that you would have a front end layer, which is a client layer, which is where your application or website actually renders. Then you have the server where all the API logic is written, and the database. So client cannot directly communicate to the database. It will make an API request, and then API would authenticate the user, authorize, and see if the user is authorized for the operation, and then send the information to the database to query it from the database and send it back to the client. So this is a security measure which was implemented, and now this is like a most widely used high level architecture in any web application, or even forget web application, even for mobile applications, you would have the same thing. The client would be the mobile browser or the mobile app in that case, but there would still be a backend server and a database for authentication as well as for querying anything. You might still find some older websites which are still monolithic, where directly from the front end we are making query calls in the database, but that is mostly outdated and it has mostly been removed, and you'll only find it in some older non-functional websites. So this is more or less the architecture, and we are using a use case of social media, and we'll keep this use case throughout the example. I mean, we'll just modify this same use case and see how various things work, whether we are using JWT or we're using something else. So like this is one typical flow. Client makes a request for a login. It will send the username, password, credentials to the server. Then server would validate the client from the database, whether this is whether these credentials are valid or not, and it will get the answer. Suppose it gets the answer as yes, it is allowed. It will send it back. Or if it gives an error that this is not a valid user, or the credentials are wrong, username or password is wrong, then similarly the message would be sent back to the client via the server. Now, once you have logged in, then you can so suppose this is a social media use case we are taking. Once you have logged in, then maybe you find a post, you can like it, you can comment on it, and every time it will be the same flow. Client makes a request to the server first checks whether it is allowed, and if it is allowed, then it performs that operation and sends the information back to the server, which it relays back to the client. Similarly for comment. So this is just the basic use case of how a basic web architecture works. Now coming to user sessions in this. So how sessions are saved and used. Now sessions can only be saved in the database to be secure and accessible. We can't actually save it on the backend layer, the API layer, if you want to save a session here. Now the problem is, once suppose the server goes down, maybe your an error case was not handled, and because of that your code has crashed and you need to restart, then you lost that session. So you cannot actually store it in the server. It can realistically only be saved in the database. Now on login, server creates and stores a session and token in the database. So this is a traditional way on how we are using sessions and session client. So suppose I've logged in. So the backend would create a session for that, and it will create a session token, which would be the information of that of the session that would be saved in the database to verify if the session is valid or not. Because suppose you have a case where you're allowing only one login from one device. So suppose I have logged in from my phone, and my session is that session client information, session token is saved in the database. Now suppose I'm trying to log in from the browser. Now that is overridden that. So next time if I try to send a request from my phone, it will ask me to log in again because the session would not be there in the database. So initially the session token is saved in the database. That session token is sent back in as there is a either as a cookie or in the body of the response back to the client, and then the client would use the same token to verify if its request is valid. So suppose I've logged in and now suppose I logged into Twitter and I'm trying to like a tweet or retweet a tweet. So in that case, I'll while sending that like operation, sending the API request to the server, I will send the same session token. And now there are two different processes which you need to understand here. One is authentication and one is authorization. We often get confused between the two. So authentication is server checks if your login is still valid, and authorization is server checks if the user has necessary permission. So authentication is the part where you are just checking if the session exists or not. If the session is gone, then it's so you'll get a pre-flight response in that case, and you'll automatically be asked to log in again. And authorization is like if I'm trying to access something which is like something which is only restricted to admin. So in that case, I'll not have the necessary permissions. So these are the two cases which are checked. And authentication is one which you should always check very quickly. And that is why we had the problem of getting JWT in the first place. Well, coming forward to it. Now, let me just reiterate the diagram. Now we are using the same use case, social media, and what we are doing here is we are first user is trying to log in, and then the user is trying to save a comment. So maybe a reply to a tweet, maybe a reply to a post, a comment, anywhere, a comment or a post, anything you can say. So what is happening is first you are sending the login credentials, username and password. That is authenticate. The user is getting authenticated from the database. That information is sent to the database, and then you get the information. Okay, it is allowed. So once it is allowed, a session is created, and the session and session token is stored in the database, and the session token is also sent to the client. Now, if the user is making another request, say if it wants to save a comment, it is sending session token plus comment text. I mean, you all would relate this with JWT. We send JWT plus comment text. So JWT is a type of token, and that is what creates danger, because JWT is a type of token which we do not store in the database. That is the idea of it. So here what we are doing is we are sending the session token and comment text. So first session token is sent for DB. This is the authentication process. And DB is sending back the user info once it is authenticated. If it is not, then it will throw an error in this step only. Otherwise, it is sending the user info. Then it is checking for authorization. If it is authorized, basically it is first checking the session token if it is valid, and then it is checking for the authorization because it is querying something. If it is authorized, then it will send back the user info. In this case, if suppose I'm authorized to comment on a particular post, then only I'll get this back user info from the server. And then I have received the comment text, so this can be saved in the DB in the necessary field. And once I've got this information, I'll send it back to the client that your comment has been saved. Now, what do we have as a problem with this process is this is a very expensive operation. That for each and every API request which is made, we are we're making a call to the DB at least twice. That we are first authenticating and authorizing the user and then commenting on DB, because that session can only be verified from the session information which is there in the database. Whether it is a Postgres database, whether it is a Mongo database, does not matter. And whatever we are using as an API layer, if we are using Django, Python, or whether you're using Node or Java, it does not matter. it's the same for all of them. And similarly for the front end using React, Angular, or any other library, it wouldn't change. This process, this is common to all web operations. This will, like, wherever there is permission or there is user session, it will work in this way. Now, this is a very slow process, as I explained, because every time this authentication has to take place. So there needs to be a way around this. And that is what the entire research in the industry has been all about in the, I would say, in the previous decade completely. I have seen these changes in front of me a lot of times. So let's come to the next one. So what are the problems? One is the database lookup. So it slows down the request every time you make the request, or that authentication from the database takes place. So there is a slowing down. And what can we do as a way around? One is to eliminate lookups. That is an example where we use JWTs, where we actually don't make this call to the database. We get user information in the token and we verify that. The server only verifies it, and then it just sends it to the database. So you're eliminating this call using JWT. So that is one advantage. And the other one is to reduce this time. That is, make this lookup very inexpensive. Like if you want to make this lookup, I can do it very fast, and it wouldn't matter if I'm making 2 different calls. So API time would not exceed. That is if you're using something like a Redis cache with a DB, or maybe Redis is the primary database. We'll come to that. So these are 2 types of solution, 2 types of workarounds that you can have for this problem which you're facing. So let's come to JWT first, which is the case where we are completely eliminating this step, session token step. So let us first see how the JWT is constructed. So this is an encoded JWT, and this could be decoded. There are various websites you can just go and play around with a JWT. You'll find all these information. So the header contains the algorithm, which is so some algorithm, say HS256, that is HS256, or you can have MD5 or any other popular algorithm. And also there's a type mentioned that this is a JWT, or JSON Web Token. This is a payload data, which is where you have all the user information. So suppose there's a user tuple saved, where you have, say, first name, last name, email ID, phone number, and say 10 other fields. So that entire payload data, that is the user data, that is also stored. You see, this is the pink part, which is the payload data. The red part is the header, which contains algorithm and type. So what this algorithm does is it encodes this entire information, header plus payload data, into such keys. So this is an encrypted version of the header and payload data. And that encryption algorithm is mentioned in the header itself, that is HS256. And just a minute. And then there is the signature. That is the security step of JWT. So suppose that signature would be unique. It is a U256-bit secret. Just a minute. I think I should take it to this side. Yeah. So, and the secret encoding. So once you have this signature, this signature actually provides you that security, that if you're, so if someone is trying to change a payload data, if I found a key, decoded it, and suppose here I've changed the email ID so that I'm able to use that token, even if I didn't have the permission, then this signature itself will change, because that signature is created once this encryption is done. If you change anything here, this encryption will change and your signature will change and the key will not be valid. So this is a security which sounds so good so far, that this is a secure token, and this also reduces our checkup time. So it's good to use. So let us just see what changes when we use JWT in the previous diagram. So this was our earlier use case where we are sending the session token all the time. Now here the login is the same. You're authenticating the user, you're storing the session. Actually, oh sorry, I think this is a misprint here. We're not actually storing the session in this case. You might this is not actually a misprint. This is something which will come to in the future cases, that we would still need to store sessions in some cases, even if we are using JWT. I'll come to that case later. For the moment, you can ignore this, that we're not storing any session. Just take a simple case. You're authenticating the user. A JWT is created with the user information by the server using the server information of a verifiable signature. That JWT is sent back to the client. It is stored, and then from for all the future requests, the JWT token and the comment text is being sent. Server is verifying only the JWT if it is signed, and if the algorithm is correct, if the information has not been hampered with. And once that is verified on the server level, then you can perform these operations, save the comment to DB, and send the comment saved status back to the front end, the client. So this is how JWT makes the process much faster. Now coming to the potential security issues with JWT. So there is this problem of none algorithm. So let me just go back to this slide. Now JWT, the problem with it is that it's a JSON Web Token, and this JSON does not have a lot of restrictions, which it should have. So suppose I have this algorithm which is 256. I have taken this token. Now I change this to algorithm none and generate a token. So now it's not a decrypted key, and if it's not handled on the backend, then what happens is algorithm none. Basically, you can just pass in any information then, because if it is not algorithm none, then there would be no signature because there has been no encoding, and basically you're just passing that information. That information would be verified by the server because it does not have to check for any algorithm, and does not have to decode it anyway. It does not have to check for the signature, and thereby you're able to completely surpass the server verification process, and now your database is prone to attack because maybe you're trying to feed something, maybe you're trying to spam the database, maybe you're trying to delete something in the database, and you're allowed because your JWT has been changed by allowing this algorithm none in the header. Someone has maybe intercepted it, found a JWT, changed it to algorithm none, and recreated it. So, but this can be handled. Obviously, as a backend developer, you can handle for a case if there's an algorithm none, then a default algorithm should be applied and the signature would have to be verified. Otherwise, it will not be allowed. Or maybe algorithm none, it will simply reject the token, whichever way you want to handle it. But it can be handled in the backend. So, like, this is a security threat, but it can be handled. But the question once again comes to this only, like, if there are a lot of security threats, then why do we want to use so many workarounds? Why do we want to use something for which we need so many workarounds, and we'll need to consider so many cases if we have some other option? So once again, like, the burden of not allowing algorithm none, that will lie on the backend developer. Then there's another issue, which is all the claims which are there in the token. So whatever is there in the payload, and apart from that, whatever information which you are storing. So suppose that would be the token expiry time, when the token has been created, how much information the token contains. So, and expiration, or for whom it is valid. So audience can also be determined, like maybe you're just whitelisting some IPs from which you're accepting requests. So that audience is defined, issuer is defined, subject is defined. But all these fields are optional. So I can just send a token without any of these fields, and so the default value would be applied and it would be valid. So once again, for all these fields, the backend developer would have to apply the checks that the audience should not be none, whatever the audience is intended should be there, a default expiration time is there, issuer is there, subject is there. So all these things, all the information which the JWT carries, these are optional, and that creates a potential security threat because you can pass in an empty JSON there. Now coming to the next part, what are other considerations which we have in real world applications with JWT? So here I'll come back to the part which I was explaining, which is storing sessions. So one is the length of the token, definitely, because you'll see a lot of real world applications. It has the size of the user table, one tuple, that size keeps on increasing because we keep on linking more and more data to the user. So we're trying to profile a user, like an e-commerce is trying to understand what kind of a user you are. So maybe it will start showing your demographic information. It will start So based on the demographic information, and that demographic information could be like 20 different fields. It could just be your age, gender, etc. Age, gender, city, etc. It could also be your based on your purchasing patterns. It could also be based on the languages you speak or where you're located. It could be anything. So or your interests, your past interests, which you have shown on the site. So those kind of information, and on the basis of that, it will map what it should show you. And it can also store information about your IP address, how many requests you're making, because like especially in social media, if you see, if you try to spam something, then automatically you'll be blocked after some time. Like if you go to Twitter and if you're following a hashtag and you just feel like you want to support the hashtag and you just want to retweet all the tweets in the hashtag, you just keep on pressing the retweet button, and after some time Twitter will stop you from doing it. You'll not be allowed to retweet any more tweets for some time. So these kind of information are also stored with the user in the in any real world application which has grown to a large level. So if we are growing that information, we're also increasing the size of the token, and there might be a case where it will reach the cookie limit, and then similarly it will slow down all the process, each and every request, because there's so much data which has to be verified. Then obviously this I was coming to this part only. Now this is supposed to be stateless, that we're not storing a state in the DB. We are only verifying it as a server. But in real world application, we would be storing a session, because for the use case which I just mentioned, the IP information. So like social media sites, they would want to restrict how much you're spamming. So they would want to block you. So they would probably get some IP information, probably even get your MAC address information, your unique, any information which makes you a unique user, from which they would identify what you're doing. So all that information has to be stored. If that information has to be stored, then that like IP information, in fact, that has to be stored. If that is there in the database to see how many calls you're making, then that is something which cannot be a part of JWT. And that is something which has to be verified by the server, that okay, you have made 10 calls in 1 minute or 30 seconds, and now you cannot make any more API calls right now, at least for another minute. So that information would still be verified from the DB. And if we are still verifying it from the DB, then once again, we have reached the original problem of this one, the slows, the session token and the verification process. So these are the other considerations which we have, where JWT does not fails to make up for what we are intending to get from it. Now coming to the actual dangers of JWT. So what happens when you log out a user? Now what can happen is JWT have a default expiration time, which is always defined. I think those of you who have worked on JWT, you have always defined a token expiration time and a refresh token expiration time. So suppose I have logged out of Twitter. Now but my JWT is still valid. Suppose Twitter is using, now Twitter actually changed it, but suppose Twitter is just using JWT to verify you. I have logged out from Twitter, but my token, that token which I'm spending, that is not expired. I'm making another request from Postman to like a tweet, even though I'm logged out, or maybe post a tweet on my behalf. And it is verifying the JWT. It says that the JWT is still valid. It has not expired. It is allowing me to post a tweet. Now I had logged out from Twitter. I was not allowed. I should not have been allowed to post a tweet, but I have been allowed to post a tweet. I tried it from Postman and I could do it. So this can potentially happen when you're using JWT, that because why it happens is because you're storing the JWT. So you're not storing the JWT in the database where you're just deleting it, and now you'll be asked to log out. JWT is an information between client and server. If the client has it saved in a local storage, it is making a request. The token is not expired. So once again, you're able to function. So logout doesn't really work in that case if you have very large expiration times. Similarly, if you have blocked a user, maybe you're the admin of the application, you have blocked a user from your site for some reason, for some security concern, maybe, but that user's token is still valid. So once again, you reach the same problem once again. And this can be with all various forms of data also. So like if it is containing the expiration time, it can also contain stale data. So what do we mean by stale data here is, suppose I was an admin user of a website and I had the permission to perform various operations. Now that admin access has been revoked from me. But the original token which I had in my local storage, that is still valid, it has not expired, and it is still an admin token. Now, once again, I make the request, I'm still an admin. I can still perform all the admin operations. So these are the cases where JWTs pose a real security concern. If you log out, if you're and as an admin, if you're blocking a user, if you're revoking the permissions from a user, and if that permission stays for a longer time because the token is still valid, then that poses a real threat, security threat. Then people have also thought about a workaround this because JWTs are often unencrypted. Like we can see, this is something which you can, if you get a token, you can just decode it on a website. You'll not actually get the signature because the signature is generated. So you can still see the signature, but this is easily decoded. So we also have a workaround which is called JWE, that is JSON Web Encoded Tokens. But what is the problem with JWE? Once again, the client does not have any information about the encryption. So suppose on the server side, I've created an encryption of the JWT. I have an encrypted JWT, and that is via a key. But I'm not sending that key to the client. I cannot. Otherwise, what's the point of that encryption? And if I'm not sending this key to the client, then the client cannot get any user information from my JSON Web Tokens. So JWEs also do not solve the purpose of dealing with the encryption. So it has to remain unencrypted. And the main problem is its validity, the stale data and the blocking logout. So let us just summarize the various cases and workarounds and how they all fail in dealing with what we need in a client server sort of model. So what we can do is changing the signing key to invalidated token. So suppose I'm trying to revoke a user and that user is still, I'm the admin of the website and I'm changing the permissions of a user. Maybe he was a moderator and now I'm just changing the permissions to user itself. So what happens in that case is, for that, I have to invalidate token, and for that, I'll change this signing key, this 256-bit secret, which we have for signing this encrypted, this algorithmic encrypted data. I'm changing the key itself. But if we change the key, then all tokens would be invalidated because the key would change for all tokens. Now the key which the server is using to validate whether the token is valid or not will not work for anyone. So I was trying to revoke the permission from one user. What I've done is I've basically logged out all users from my platform, and everyone has to log in again. So that gives a bad user experience. Now, one is saving a list of revocations on the server. So suppose I have revoked some keys and maybe change the permissions of some keys, and I'm maintaining a list on the server itself, on this API layer, server layer, that these are the tokens which are not to be validated, which are not valid. So suppose I'm storing them as constants. Once again, what if the server goes down? That is there in the code. As long as the server is running, you have that information. If the server goes down, then once again you're left without any information, and once again nobody is allowed to log in or do anything. Basically, everyone would have to log in again. Now, once again, there is also a workaround that if an ID is added to the token in JSON Web Token, whose data is stored in the database, that I'm storing that ID and I'm verifying only that ID, then once again we have created the same problem of using the slow session tokens again. This original case where if we're verifying the ID, it's as good as verifying, because we are making that DB call to the server. We're making the call to the database. So in this case, we once again reach the same problem of using session tokens, which are slow. Also, if we are storing JWT in a local storage, once again, it can be accessed and stolen by some JavaScript, some CDN scripts. And then if it is stolen, then obviously there is a huge potential danger. Then there is also this case of which is the only workaround which I've seen with all those organizations which are still using JWT. So that is, they are making it very short-lived. So what happens is that it would happen in your Great THR also. I think you would have seen, like in Great THR, you're mostly asked to log in every day. Like whenever, I'm not just talking about sign out process. Like if you go to Great THR today, you don't log out and you go back again. So maybe in the evening or maybe tomorrow, you'll once again be asked to log in. It will not, even if you've stored your information there, because the token would expire. So if JWT is made short-lived, once again, it gets a bad user experience because you'll be asked to log in each and every time, again and again. So overall, if we see all these cases and all the problems, then it only says that all workarounds would fail for a client-server process, and JWT is strictly not recommended for this. But it does not mean that JWTs are of no use at all. Like if we have like server to server communications, so suppose we have microservices where only servers are communicating with servers, and we don't have to care about log out if users are logged out and asked to log in again, because it is one server trying to communicate with other. There, JWT is a very good use case. JWTs have a very good use case. I mean, you can use JWTs there. It's not a problem. It's only in the client server model where it poses a real security threat, because it's storing it in the local storage. There it is prone to attack. It is not expired. You're changing the access and nothing changes. You're revoking access, nothing changes. So all these are major problems of JWT, and it should not be. I'm sorry, is someone saying something? Hello, I'm sorry, is someone saying something? Is there a question or something? I'm just hearing multiple voices at the same time. If anyone has a question, you can just write it in the chat and I'll just come back to it in 5 minutes. So anyways, continuing. So the summary of it is, like, for a client server model of development, JWT is not recommended because of all the security concerns, and also because of the way modern applications are, the size of the user data which we have there, and also the size of the also if we are storing some IP information or some unique user information, that will still require DB calls. So JWTs do not actually serve a lot of purpose there, and it is only good for server to server communications. So now we have discussed what are the problems with using JWTs. Now let us come back to this second part, which is the workaround. The second workaround, that is making the lookups much faster. That is the use of Redis. So what we do here is all this session information. Now this is the original diagram only. Now what it does is, wherever we're using Redis as a caching layer, that communication is very fast. So the storing the session and looking up for the session, sending session token, sending user info, you're checking, see, if you just see these steps have become very fast because of Redis. Because you're storing it in caching layer, that caching layer is being like in a cron fashion, it is updating the database at the same time as a background process. But mostly you're communicating primarily with Redis, and that is where you're storing the session as a cache. So you're using Redis as a caching layer here. And this process becomes much faster. And thus we are solving a problem without posing any security threat that the token might be invalid or something, because the token is still stored in the database and as a session token, and it is verified every time. But we are eliminating the lookup time. I mean, we are reducing the lookup time by a lot less. I mean, there's like infinitesimal compared to what it was in checking from the original database. So that is where Redis comes in very handy. And so once again, it's the same use case. What I'm just trying to show is these processes have become much faster and we have solved a problem. Now, it is not the end of it. Basically, if we see the development in Redis, I've also provided a link in the next slide, which is just for an integration of Redis with Node Express. You can have a look at it. I'll also share the slide with, I mean, it is shared with the Valuebound. I'll just send the link once we're done with this. So what we can do is I mean, we are having Redis as a primary database, which is just syncing up with the database. All these processes are just handled by the Redis, because in modern day development of Redis, now Redis also supports JSON, like JSON based documents. So basically we can also integrate it with Mongo databases and NoSQL databases. I mean, it's not like a recent thing. Redis has been supporting it for a while now. I'm just mentioning that earlier Redis only came in as a cache layer. Now it is so powerful that it can be used as a primary database in itself, and which would be communicating to your actual database and syncing with your actual database. So and it also provides the Redis search. So now what we have, one is like Redis has integration with all modern languages. This Node Express doc I've already mentioned in the link. It can be used as a primary database, and so basically we are storing the session information as well as all the database information side by side. So here we are only storing in the caching, we're only storing the session information, and whereas the rest of the information in the database, and so that we are storing everything at once in the Redis, and only the database information we are sending to the DB. We're syncing with the DB, main DB. That is the background process. So it supports JSON. So once again, it's good for Mongo database, and it actually now provides real-time full text search also. So whether we are using Postgres or Mongo or any other database, we can apply some sort of an elastic search on the Redis database only and get information in very quick time. So Redis is like, you can just use it as a primary query in your case. So yeah, that's it from my side, and I'll just show this also once. So you can just go through this doc. This has just provided a very simple information, very simple integration with Node and Express for Redis Cache. This is there in the PPT, and that PPT I'm just going to share right after this session. And as you can see, all the API calls and the query logic which you're seeing, these are communicating with the Redis only. We have created a Redis client here, a new Redis store, Redis client, which is added to the database. And now Redis is your primary database. All the querying, all the information, storing information, everything is being done to the Redis table only. That is in itself communicating with the actual database. So this is Node with SQL, and we have one example here. So, all right, I'm done from my side. So if there are any questions, I think we can just move back to the chat. I'll just stop sharing for once. Okay, I can't see anything in the chat. Is there any question which any one of you who's in the meeting would like to ask regarding this? Just one question from my side: was this too convoluted to understand, or was it simplified?
Yeah, it was very simplified actually. So if there are any questions, you can now unmute yourself and you can ask the question directly.
Or you can just raise your hand, or we can unmute. All right, I don't see any questions, so I think we can wrap up the session right now. We anyways exceeded the time.
Yes, so it was very informative session, someone. So thank you so much. Despite my non-technical background, I was able to grasp a lot of things here. So thank you so much for that.
All right, thanks for joining, everyone.
Thanks for joining, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Welcome.
Thank you.